Welcome to Ask and Learn.
So with this problem, you're given a sphere and the goal is to find where within the sphere and where outside of the sphere is the electric field a fourth of its max. So I'm going to go through this one kind of quickly because there are other problems that are basically related to the constituent ideas. And so hopefully you've seen the main ideas before. So the first thing we want to do is find the maximum field. And so basically, if you've seen any problems that were like finding the electric field within a continuous media, i.e. not just a shell of charge, but a continuous set of charges, it just grows linearly. For a spherical distribution, it grows linearly with the radius. You can figure this out by making a Gaussian surface in the inside at some radius and figuring out the charge enclosed and figuring out and using that and then the flux and Gauss's law to get the electric field. And you'll find that it maxes out when you've enclosed all the charge, and then it starts to decline as you go further out. So if you were to draw the electric field, it's like something like this. So, and then this is the max at R equals R. And so, yeah, so E max then, I'm going to write it in a particular way that the problem 78 basically asks you to prove that this is a valid way to write it. So you can reference that problem if you want, but it's E is rho, 3 epsilon naught R, and then rho is the total charge divided by the volume. So that's E max. And then you can see here that if you want this to be a fourth of its original value, or of its, actually, this should be evaluated at R equals R. So if you want this to be a fourth of its value, it's linear in R, so then you simply just need to go reduce R by a fourth, so R equals R over 4. And then outside, though, it follows the usual 1 over R squared law. And there's a lot in this about the textbook if that seems crazy to you. And so that's 1 over 4 pi epsilon naught times the total charge over R squared. So it goes as R squared. So if you want to reduce this by a factor of 4, then you need R to equal 2R. Sorry, that's kind of messy. Because if you square the 2, then you'll get 1/4 what it is at the surface. I'm just going to write that nicely. So that would be 2R.